Hello. Today I'm going to show you how we can use Excel to determine the expected present value of a whole life assurance where the benefit amount is changing each year. Um, and if we are simply given a life table, so the life table could look something like this, or it could have even just been the LX values. But just with this information, we can use Excel to determine the expected present value of these benefits, okay, assuming a given interest rate. All right, so let's get started. So the question is, we have a whole life assurance. It pays 200,000 rands if the policyholder dies in year one, 220,000 if the death happens in year two, and so on. So every year the benefit increases by 20,000 rands. The payment is made immediately on the death. So when I'm doing my cash flow buildup, I have to recognize that I might be thinking about a probability of death happening in a certain year, but the timing of that payment is not necessarily happening at the end of that policy year. Okay. All right. So, and here's our interest rate, and here's our life table. So let's go start a calculation. Right. So I'm just going to change the heading here. So I'll copy, and to paste without changing the format, I paste special values, or the shortcut would just be HVV. To determine a shortcut, you could go, for example, if I hold down the Alt button, then you can see to get to paste, I would need to first go home. So I press H, and then the computer's telling me, Excel's telling me that to get to paste, I would go V, and then the V again. So HVV would be just pasting the values. Okay, so that's one way to determine how to get quick at Excel, is to actually go through the pain of learning the keystrokes the first time you do a command, and then it will become part of your memory, and then you would just, next time you don't have to pay attention to where Excel's showing you the letters, you would just go Alt HVV to paste special. All right, so what do we need to know? Well, we know that the life is currently aged 65. So we need to somehow come up with a timeline. So we might want to do something like year. Okay. And just for completeness, we might want to start at year 0, which is, today, and then year 1, and so on. So if I just go to the bottom right and drag this down, then it gives me a few years. So for now, let's just go 35 years into the future. And then we have to think about the age of this policyholder. So I might want to do something like an age, like just specifying the age next to the year. So the policyholder, to go to the next tab, to the previous tabs, I'm using Control Page Up. That gets me to the live table. Control Page Up again gets me to the question paper. And here we can see that the life is aged 65 exact. Let me zoom in here so you can actually see this. Okay, so we age 65 exact. So to get back to my calculation, I go Control Page down. And here I would say, okay, this is now 65. So I'll just press equal to, or what might be easy, just to press plus 65. So that's 65. Okay. Now I drag it down, and that didn't work. I needed it to be a different age in the future years. I needed age to increase by 1 in each year, but Excel assumed I just wanted to copy the same value. So now I'm going to do the same thing. I'm going to drag it down, but now I can see in the little number there that Excel is showing me it's going to just replace everything with 65. But if I hold Control, then you see that cursor changes to a cursor with a little plus sign. And now if I let go of my mouse, you see that it recognized that it increased the number by 1 each time. Okay, so now let's go back to our life table to see what's the last. Well, it turns out that that is the last life. That is the last age we wanted. So in this case, we could assume, from the time when we reach 100, then in that year, we have 100% chance of dying. Okay, so in this case, in year 35, which would be the year, the end of year 35 would be the year in which I reach 100. So there would be no more payments expected after that time point. Okay. So now what I would want to do is I need to somehow create a column maybe for the amount. If death had to happen in this year, what would the benefit payment be? Okay. So so I could just call it the benefit in this year. Okay. So let me just think about this. Okay, so in the first year, the benefit, if I go back to the question, it starts off at 200,000 Rand in year one. So in my layout here, year one is actually representing the year of age 65 to 66, because the person took out the policy when they were 65 exact. Okay, so the benefit in the first year is actually going to be 200,000. So 200. So a short way would just be 200 E3. That gets me, and then change it to a currency to look like a rand amount. So I could just go rands, something like that. Okay. Now I want this amount to increase by 20,000 each year. So in this case, something as simple as saying it's that number multiplied by, oh, sorry, not multiplied, but that number, I need to add 20,000 to that number. Okay. And there we have it. Now, what I could do, because I've got this column on the left already populated, just simply double clicking automatically populates my whole column. But if I didn't do that, so Control Z, another way to do that would be Control C. And to go to the bottom, I would press Control down. And then I can highlight by pressing Shift Control up. So now I've got all the cells highlighted, and just pressing Control V is telling the computer to copy and paste the same formula for all the cells that I've highlighted. Okay. All right. So now that we have the benefit, now we need to say, what is the probability that the benefit will actually get paid in that year? Okay. So to determine this probability, we're probably going to actually need a few other steps here. So what is the probability that there will be a benefit? Well, before we get there, we need to know what's the probability that the policyholder would have been around at the start of that year. Okay, so we could say something like probability that we are alive at time t. Okay, and then we could say, for example, that this column is t, which represents years from today. Right? Okay, so what's the probability that I was alive at time 0? Well, I bought the policy at age 65, so that's just a 1. Okay, now when the policyholder is age 66, what is the chance that they would be alive? Well, this would be equal to, now I'd go to my life table. This would be L66 divided by L65. But because I always wanted to divide by this L65 number, I would need to do something called absolute referencing here. So if I just press the F4 button repeatedly, it changes whether I want both the row and the column to be fixed, only the row to be fixed, only the column to be fixed. And in this case, I want both to be fixed. Okay. So that will make sure that whatever number I choose, whatever Alex value I choose, it will always divide by L65. Okay, so if let's just neaten this up make it a little, yes, not too many. Let's just go like that. Okay, so now if I copy and paste, that's now populating. So let's just do a quick check. So for example, when I'm age 90, which would be time 25 on my timeline, what am I doing? I'm looking up B29 divided by B4. So let's go there. I'm looking up B29, which is L90, divided by B4, which is L65. Okay. So now we know the probability that we'll be alive at that time. Why do we need to know that? Because now we can consider what is the probability that we will die in year or what's the probability that we will die in that year? Let me just think about this. So yeah, so in other words, this would just be Q65. So maybe this is not so accurate. What we're actually talking about here is Q of 65 plus T. That's what I really want to say here. Q of 65 plus T. And I just want to format this so that we can make it a little bit easier to read. So make up Control 1 is to format the cell. I'm making it a subscript. So that's just showing me that I'm now talking about Q65 plus T. Okay, so let me just delete that. Make it a bit easier to see. All right, so what is Q65 plus 0? Well, that's just Q65. And because I've got the QX values, that's why I'm choosing to do it like this. So I just say Q65. And then if I drag this down, it then looks up Q66, Q67, etc. Okay. So now what's the probability that there will be a benefit in year yeah, the reason I'm hesitating every time I'm saying in year, because I'm starting with T, so it's not actually, you know, but so it's fine. We can just say in the year starting at time T, in the year starting at time T. That would be a, you know, accurate way of saying it. So let's just format this so that it looks a little bit neater. Maybe make it to the top, centralize it, something like that. Okay, so what is the probability that there'll be a benefit? Well, it will be the probability that the policyholder made it to the start of that year, multiplied by the probability that they died in this year that I'm thinking about. So the probability that it would get, there'd be a benefit in the year starting at time 0 would simply be Q65, okay? And then dragging that down fills up my probabilities here. So let's just do a check. If we're looking at the year starting at time 9, in other words, the 10th policy year, well, that would be the probability that I was alive at time 9. So for completeness, we could say this is actually equal to, let's just write this out more completely. So this would be, what would this be? It would be TP65. Okay, and then I just want to make those subscripts so that they're easier to read. Then a subscript as well. Okay, so this is what I mean in this column here. We were looking at TP65. Okay. So let's go back to the year 10, which would be the year starting at time point 9. Then that would be 9P65. So the policyholder would have first had to survive all the way up until time 9. And then they would have had to die in the year of age 65 plus 9, which would be 74. So in the year between exact ages 74 and 75, they would have had to die, which is that 65 plus T column. Okay, so now I've got the probability that there'll be a benefit payment in the year. Now, if there is a benefit payment, when will it get paid? So this represents the probability of dying in the whole year of age. But because in this case, so let's go back to the question. In this case, the death benefit is paid immediately on death. So that means we could say that on average, we'd be paying the benefit halfway through the year. Okay, so we could just create something called a discount factor. Okay, and if we wanted to be explicit, we can even say what do we mean by this discount factor? Well, we mean v to the power t plus half. Okay, so v to the power t plus half. That's what I mean. Okay, so just clean up that bracket. Oops. Let's see there. Okay, v to the power t plus half. That's what I mean. Okay, so in other words, if I died in the first year, I'd expect the payment to be roughly 6 months into that first year. So what is v? Well, we could code it somewhere here. So let's put our I, which is our interest rate. Say I, right, align it there. I is 6% per annum. Okay. So this thing here is our thing that we can look up whenever we want an interest rate. So I could even call it, for example, I could name the cell interest if I wanted to. Okay. So what is my v to the power t plus half? Well, it will be 1 plus interest. I could type it out or just click on it. 1 plus interest to the power minus minus something. What is that something? It is t plus a half. Okay, so that's the discount factor. I don't need so many decimal places, so let's just do 6. Okay, so that gets me my discount factor all the way up to time 100. Great, so now we can work out what is the expected present value. And we could call this like the contribution to EPV of benefits. Okay, these are not very nice names, but what is the contribution to the EPV of the benefit? Well, the benefit, if we get paid here, it would be 200,000 that gets paid in the first year. What's the probability of payment? Well, I'm going to multiply by that probability that the benefit is getting paid in this year. And then I need to discount it by half a year. So I would multiply that by this v to the power half. Okay. And if I do that, I'm just going to take out all the cents here and make it rand. So I'm going to format the cell in the same way that I formatted the benefit column. Now I drag this down and it gives me the EPV in each of these years. Okay, so the EPV is increasing even though there's a bigger discount factor. Why? Well, it's increasing in this case. Funny, it's actually doing something weird here. It's increasing and then decreasing. So there's like a bit of a offset happening. The reason why it would be increasing is because the benefit amount is increasing. The reason why it might be decrease, what would make these amounts decrease is because we're raising it each time, we're multiplying it by a factor of v to the power t plus half, where t is becoming increasingly bigger. So the discount factor is becoming smaller and smaller. Okay, so let's just double check that we've got the right thing going. So in any given year, we're saying it's the benefit amount multiplied by the probability that there will be a benefit in that year multiplied by the discount factor. Okay, so that's the EPV. So now if we wanted a total EPV of the benefit, we could just say something like, we could do it right at the top or at the bottom, it doesn't matter. We could do something here. We could say EPV of the benefit is shift space. So I want to add a row here. So I go shift space to select the whole row, shift control plus to insert a row. So what is the EPV of the benefit? Well, it would be the sum of all these possible present value of all these possible payments. Yeah. So that is my EPV of the benefits. Great. So that's the first part of the question done. That's how I calculate the EPV of the benefits. Just for completeness, I'll put the things that I'm calculating in a different color. Great. So now let's add some complexity to the question. So now let's suppose that in addition to determining this EPV, let's suppose we needed to price this product. So let's add to the question, right? So let's say now, suppose the policyholder pays an annual premium as long as, is it a he? Let's just assume it's a male, as long as he is alive. Or let's just suppose that, but he's not going to pay premiums for more than, let's say, 15 years, right? So when he reaches age 80, there's no longer premiums. Okay. So even though the benefit will carry on, let's suppose that premiums have to stop by the time he reaches, or let's suppose it has to stop by the time he reaches 80. Okay. So he pays an annual premium. Well, now we're changing the criteria here. So he doesn't pay an annual premium every year. He pays an annual premium up to age. We could decide whether it's up to and including, or we could say premium up to a maximum of, or pays an annual premium for a maximum of 3 years. Okay. And so the question we want to do now, what we want to do now is to say, well, calculate that premium. Okay, so let's go. So now we've done the benefits. Now we need to do a premium calculation. So for starters, let's just assume it's always easier in Excel if we just create a dummy cell to hold this premium, and then we can do things with it. So what we didn't say is the premium doesn't change. So let's say here that we're going to say pays a level annual premium. So let's suppose that this is the annual premium. Okay, it's something that we're going to end up calculating, but for now, let's just say it's 100 rands. Okay, so in each year, we are going to say what is the premium that we would pay if we were alive in that year. What would be the premium? If the policyholder was alive, what would the premium be in that year? Well, the premium in the first year would be the 100, okay? But it wouldn't. We would have to make sure that we only do premiums for the first 15 years. In other words, the year starting at time 14, and from the 16th year onwards, which would be the start of the year, would be time 15, there'd be no premium. So, I mean, in this case, it's simple enough for us to do manually. So let's just do it manually. We would say let's make this always equal to the premium value, okay, up until 15. Okay, and then in the future years, so let's just count. If I highlight everything, I can check that I've actually got 15 years worth of premiums. And then I would just say it's 0 after that. Okay, so copy and paste to get the formatting, and then I'm going to make it 0. Okay, so now if I double click, okay, it's not taking me all the way to the bottom because I've left a blank column, so it's not picking up. That's why the double drag isn't working. So so what I can do is I could just do Control C, go all the way to the bottom using the column, 2 columns away, and then highlight everything, Control V to paste. So now that we've got our annual premium column, we can say, what is the probability that we would be paying that premium? So what is the probability that this premium will get paid? Premium gets paid. Well, the probability that the premium gets paid is exactly equal to the probability that the policyholder is alive at the start of that year. Okay, which is probability that we're alive at time t. So I could just say it's equal to that, right? But only for the first 15 years. After that, there's 0 probability of a premium because we don't have any premiums after time 15. Okay, so now I've got the premium and the probability that the premium gets paid. So I need another discount factor because the timing of the premium payment does not match the timing of the benefit payment. So I won't be able to use the same discount factor. So I need a new discount factor for the premiums. And this discount factor is going to be the discount factor that represents payment at the start of each year. So it's simply going to be v to the power t. So the discount factor here, I'm just going to copy and paste and say, instead of 1 plus interest to the power, okay, it's moved by t, so I'm going to move it back to t there. And instead of adding a half, it's just going to be v to the t. So I just need to do that. Okay. Now, I can just, it doesn't matter that I'm letting this discount factor go all the way because those probabilities are 0 anyway. Now I can say, what is this each year's contribution to the EPV of premiums? Okay. So the contribution is going to be, well, what's the premium amount multiplied by what's the probability that premium gets paid multiplied by what's the discount factor to bring it to times 0. Okay. So that is a random amount. So I'm going to make it the same format. And that's the contribution to the premiums. Now, in this case, using the principle of equivalence, we can see that these premiums are going to be way too low, right? Because if I have to work out what's the EPV of premiums, here, I've copied and pasted and it does it automatically for me. I can see that my benefit is almost 170,000, but my premiums are not even 1,000 Rand. So clearly, this 100 Rand premium is way off. Okay, we could do some trial and error. For example, would 1,000 Rand premium work? Well, we're still very, very far off. With 10,000 a year work, starting to get closer, but we're still way off. Okay, so instead of doing trial and error, I can get Excel to do the work for me. Okay, so now we can say we're going to use something called goals to determine the premium. And just to set this up, I'm going to say, for example, let's say we're going to do this calculation on the right here, right? So we're going to start off with what's the EPV of the outgo. In this case, the EPV of the outgo, it's only the benefits. We're not thinking about expenses. So the EPV of the outgo is simply that EPV of benefits. Okay. What's the EPV of the income? Well, the EPV of the income is simply going to be the EPV of premiums. So I can just say that is equal to that here. So this, sorry, this should say EPV of premiums. Okay. Now I want to know what's the difference between those two things. Okay, so I just want to create a column here to create some space. Okay, what is the EPV of the outgo minus the EPV of the income? Okay, so minus EPV of income. Let's do it like this. Okay, what is this? That is just, I'm going to say it's equal to the outgo minus the income. That's 70,000. What do I want this number to be? So, for example, I could say, what is my target for this number? My target is actually 0 rands. Okay, so I want to see how can I get this number, this difference between EPV of income and outgo, to be 0? Because then I'd be solving for the equation of expected present value of the outgo is equal to expected present value of the income. So how would I solve for this? Well, I can get Excel to do it for me. So I can say, we go to tools. Now I only know the shortcut, so I'm going to have to learn so it's data. Right. So I'd go to data, what if analysis, and then I would go to goal seek. Okay. So now let's try and create a shortcut to do that. So I press Alt. A is to get me to data. I can see that here. So A gets me to data. W gets me to what if analysis. So AW gets me to what if analysis, and then G gets me to goal seek. So G gets me to goal seek. What value do I want to set? Well, I want to set this EPV of outgo minus income. So that's the value I want to set. What value do I want it to be? I want it to be 0. So I can just click, there. Select it. And what do I want to change? Well, I want to change the premium because I can't change the benefits here because these are the benefits under the policy. I don't have control over that, but I do have control over what I charge the client, the policyholder. So I can select the cell that I want to change is the annual premium. Okay. And then I'll press OK. And you can see it's done a calculation where it's determined that if I charge 17,271 rands as the premium, that gets my EPV of the premiums to match the EPV of the benefits. And I press OK. And that's it. That's how we use GoalSeek to price the contract by setting the target for the EPV of outgo minus EPV of income to 0 by changing the annual premium cell. Thanks very much.